I'm Jean-Louis Baudoin, I'm Capgemini architect, and I'm very pleased to co-animate this return of experience about predictive monitoring with Christophe Lejeune from DGAC.
Yeah, good afternoon, everybody. I'm Christophe Lejeune from DGAC. What's DGAC? It's a French civil aviation authority. DGAC has the foreign missions of the state for air transport, like air transport security and safety. Is also the regulator of the economy of air transport, and the main mission is air traffic control. So the DTI, Innovation and Technical Direction, is the industrial architect who develops air traffic control tools, which includes system validation and deployment in air navigation centers. As you can understand, the system installed at the DTI are representative of the operational, which includes system validation and deployment. The context, 1,000 users, developers for 80% or project manager. 3 years ago, several major incidents were encountered due to the obsolescence of the infra. Yes, I say obsolescence. I have to say, during this incident, I have above my shoulder, my direction, business, clients. The question was both, how long? And what is the impact? And it was very difficult for me to answer to these questions. So I decided to launch several major innovation transformation projects as automation with Ansible Tower, AI, and hyper-converged infra. So what's the needs for this project of monitoring predictive? First, we have 500 applications. We classify these applications on 5 critical levels. And among these applications, 40 are very critical applications with 300 assets. The target is surely high availability. Second needs, we were in the old world on my mind. That is to say, we have IT tools, technical IT tools like supervision, central, application logs, system logs, and it's very difficult to manage with this data to analyze complex root cause. So the need is to have monitoring predictive, to give to my clients an application view, and also to know and to ensure business availability. The last needs, it's a cost of a crisis. As you can see, we analyze the past 5 crises by year. It's a lot for me. And the cost of one crisis, a crisis involves 500 users. The duration, 3 days, And surely we have a crisis team, which involved 9 people. We don't care with the details of the people. It's up to you, Jean-Louis, to present the solution.
Yeah, thank you, Christophe. Well, I will talk about a solution called Thunderstruck. What a strange name. Where does it come from? From a song of AC/DC. In French, Thunderstruck is the war. And this is the origin of this term. Well, this is a framework about ITOA. What is IT Operation Analytics? It's an approach to centralize all data. All my data that are in silos about my infrastructure, my application. So you could have some monitoring data about my GB, monitoring data about my network, and so on. But you do not have to limit ITOA to such a unified login system. This is more. Because you have the terms analytics, you could do some intelligent things. With all this data, we could do some analytics computation, and so that you could, as I mentioned, prioritize, do some assumption, and so on. Well, what about the main future? As Christophe mentioned, he has in mind user, and user are applications in our case, in our IT cases. So the solution has been built with this idea. Application is the main entry point. Well, if we analyze the 3 main features, we have first the idea that we want to predict the future. So to predict, we need to know the past. And we have to collect a lot of data. This is typically a big data project because we have a lot of sources. Remember the different silos that we have with database, network, and so on. After that, when you have collect your data, you could consider your issues, and you have to categorize them and do some sets of data that characterize these issues. And of course, we can learn some pattern, some anomaly pattern. This is where the AIA starts. This is not sufficient. After collecting of the data and learn some models, we want to have some predictions, some detection of issues, of anomalies, and of course, predict the state of the future system. The main question is, what will be my infrastructure into a couple of hours? Is it working or not? Are my applications up or down? This is the main question that we want to solve. Of course, when an issue is predicted, this is a good idea to alert the team that a problem will occur. And I say will occur. This is not is occurring. And the last but not least is to start remediation. If you have some process, some automatic process that are already available to fix some issues, we could launch them to try to fix or to prepare if you are in a mode where you know that the system could be fixed by a set of action like reboot and so on. What it is built upon? Well, remember that we have a lot of data source that we compute, and what we do with it, we build some nice user-oriented dashboard like application Meteo, but in the future, we have the now moment and the future moment. And this is because it is interesting to solve the DGAC problem, to reduce the crisis team, because we will know in advance what components will fall, and of course, in this case, you have just to mobilize the right people at the right time. Under the hood, we do not be very originals. We use, of course, Python, a scientific distribution of Python called Anaconda. We also use classical libraries like the Google TensorFlow, Scikit, and in some cases, we use also Facebook Prophet, that is a trend library. And of course, this is not be efficient if we could not be elastic. I do not enter into the technology, but if you know the domain, we have two phases. We have a learn phase that is cost CPU intensive. So we need a lot of compute during a certain time, but after that, when we run, we do not have the need of such computation power. So we choose to use Docker to manage the elasticity, permits eventually to go to the cloud, and of course, to orchestrate all these Dockers, we choose an orchestration platform that is Red Hat OpenShift. Well, let us now examine the benefits of, oh, excuse me. What's about the project? In the case of such a project, the project is built very quickly because we have two reasons. You need to have well data. Data need to have a good nature, syntax, normalization, and so on. And you have to have a good CMDB. So these two assumptions are helps us to have a very quick project. But more interesting than the phases into the project are the distribution of tasks. I have do a little stairs on my diagram that shows that we spend a lot of time into data and not into configuration or integration of the software. This is a major point that you need to remember because IA projects are very consumer on data analysis. Well, I let Christophe.
Now the benefits?
About the benefits. Thank you.
Thank you, Jean-Louis.
Oops.
Oh, no. So what's the benefits of the solution? As I said, my vision is the service delivery. So it's very important for me that the users are in the scope. Now, with predictive monitoring, I can give an application vision to my clients. They can see which application is available or not. The second benefit is surely innovation and IT modernization. As I said, we had several major incidents due to the obsolescence. Why innovation? Why AR? My job is to determine the strategy. I don't want to do the job of a computer. I don't want also my sysadmin ops do the job of a computer. That's the reason of innovation and of AI. The third point is to reduce the cost of a crisis. I can say to my direction, I engage my responsibility that less than 40% people will be involved in the next crisis. And I reduce the duration at 1 day. What? Yeah. Now, what's the lessons learned? First, regards to data. As said Jean-Louis, we passed a lot of time to analyze data. And it helps us to know our data regards to syntax and semantic. Also, we did a job we'd never done. We qualified precisely our issue. It's very important to predict the future. And third, we determine links between CI regards to CMDB, common database. In the other end, it's about project methods. In the past, the project was done with waterfall method. With waterfall method, I defined specification regards to my needs, and the project takes inputs, and several months later, the project presented the solution, and I was very often disappointed with the results. I miss one need, I discover a problem, and so for me, with agility methods, with agile methods, we start small. So I can see the result very quickly, a first result. It's like a painter who do a first esquisse, and you can see if it's good or not, and you increment. The second point, you can understand you are able to include new elements you didn't see before. So it's a guarantee of good results regards to the goal of the project. It's up to you, Jean-Louis, for the time of the project.
Well, there is also a final lesson learned about time. We can see that in AI projects, we are generally 2 times. A long time about data preparation, and of course, the learning time, that is not very quick, and a more short time when you run the solution. Imagine you learn during hours, but you will recognize an issue, in our case, in less than 100 milliseconds. So compare the hours spent to learn and the time of recognition. So we have always this duality of time. In conclusion, we will say that with monitoring, predictive monitoring, and in our case AR, it has been a good booster to better know the data and application that are critical in the case of DGAC. Thank you.
Thank you for attention.